6. You got a big lorry, its mass is 32,000 and it's traveling at 24 meters per second. Then it hits into a stationary car. That means a car which is not moving. And its mass is 2,600 kilograms. They crash together, and so they form a new mass. Yes, 34,600 kilograms. And the question is basically, well, the first part is, what is the kinetic energy before the collision, is the first part. Okay. And this we don't know. And this is going at 0. Okay. Kinetic energy, what's the formula? A half mv squared. Does this have any kinetic? No. So it's just the first one. A half times m times 24 squared. I got 9216000 joules. Or if you prefer, 9.22 megajoules. Part 2 is now they would like to know what is this velocity. So what formula or idea can I use here to get the velocity?
The general velocity.
Yeah, what's that? I thought I heard someone say it. No? Momentum. Conservation of momentum. The momentum before the collision equals the momentum after. So the momentum before the collision, that's m1u1 plus m2u2 equals m1v1 plus m2v2. But in this case, there's only one mass because they've come together. So anyways, you would get m1u1 plus m2u2 equals this new mass here times x plus, well, there's nothing else, plus 0. Okay, that's...
What's x?
X is the velocity. We don't know. 32000 times 24 divided by 34600, and I got velocity equals 22.2 meters per second. Part 3 is they want the loss in kinetic energy. That means I should work out what is the kinetic energy after. Again, a half mv squared, but this time it'd be a half 34600 22.2 squared after collision. A half times that squared, we get 8526132, or if you prefer, 8.53 megajoules. So the loss would be 9.22 before minus 8.53 after. That's 0.69. So 0.69 megajoules was how much energy was lost.
It's nearly a million.
Nearly a million joules, yeah.
Resulting force.
Okay. Now, the last part here says, guys, no, the last part here says, this car wreck of 22.2 meters per second is slowed down and eventually stops. Guys, are we listening? So it slows down and stops. And in the question at the beginning, it said it took 53 meters to do that. So you think these cars come together and then they start to slide. And they stop because there is a force that's stopping it. So the question is, how can we calculate the force? What's the formula for force? F equals ma. Do we know the m? We do. Do we know the a? We don't. But we just do a UVATS and we can know it. U, 22.2. V, 0. A, don't know. T, don't know. S, 53. Which formula should I use? No, I don't think so.
V equals to U plus A.
No. V squared equals U squared plus 2AS. So we get 0 equals 22.2 squared plus 106.
Isn't it 22.2 squared?
No, 0, V. S. No, sorry, A.
Was it traveling with 22.2 emission?
Yes.
Your arrow?
No, it's not. The arrow is a force arrow. It's the force is slowing it down. It's forces to the left, but the car is moving to the right. Okay, 22.2 squared divided by 106 negative, because it's slowing down. Alright, so now the F would just be the mass multiply this number. What was the mass? It is 34,600 times 4.649 divided by what was my mass? Sorry, it was 34,600. Okay. Maybe I'll do it in kilos. Yeah. It would be 161 kilo newtons. That's how much force you would need to slow this down to rest in 54 meters. 161 kilo newtons. Is that okay? Yeah.
What if you divide the energy, the kinetic energy lost by the distance?
Kinetic energy? Yes, that's another way to do it as well. Good man. There is another way to do it. I think you could say work is force by distance. Good man, yeah, very well spotted. There's a second way to do it. I might as well do it here for you, okay? So that was one way to do it. Another way to do it is by saying work equals force by distance. So what does force equal? Work divided by distance. Now, what was the work done? Well, if you think about this, I'll give you an example here with my pen. So imagine this pen is moving and its kinetic energy, look up guys, is 1 joule per second. Sorry, 1 joule is its kinetic energy, okay? If I stop this from moving, it means I've done some work. The work I've done is basically, it's like I robbed its kinetic energy because now it's not moving. So if this was moving at 1 joule per second and then I stopped it, I have done work of 1 joule per second to stop it, to counter, so to speak. So when this car is moving, the car crash, if you knew its kinetic energy, then you know how much work needs to be done to stop it. So if you just divide that by the distance, you've gotten the force. So what is the kinetic energy here of the crash? It is,
It's like the plane, like in the voice in the plane, like the other place.
which one?
It's like when force, you understand the plane. It was another force. It's like the voice in the plane.
Yes, it's the same idea. It's like a counter work almost. The kinetic energy is 8.53 mega. So if I do now 8.53 times 10 to the 6 over 53, and you know what answer I get? 161 kilonewtons. Exactly the same. So this is if you want like the second method of doing it. Much nicer and much quicker actually. I forgot about that one.